Good morning, everybody. Uh, Today, uh, I'll discuss a very important aspect of, uh, you know, foundation design, and obviously, which has got direct impact on structural behavior. Naturally, we can't think structure and soil separately because our structure is supported on soil. So, if there is any damage to takes place in soil, that ultimately affects the structure. I mean, structure may collapse also due to the damage took place in soil. So, soil is very important to us, right? Because your superstructure may be designed, properly, but if you don't give sufficient attention to the substructure, that means the foundation, then what will happen that the foundation, the soil, etc. will collapse, and ultimately the building will collapse. So these are the things, you keep it in your mind. Then you will be able to understand the why this liquefaction potential assessment of soil is so important. Now, in this regard, I must tell you one thing that for a long time, people used to discuss about liquefaction, but the code never adopted. This IS 1890 or any other code never adopted this kind of liquefaction potential assessment. And in 2016, they have suggested a few methods, and now even in the industry it is compulsory because it is in the code now. So when you are submitting a soil report or when you are designing a particular structure based on a soil report, you have to be very careful whether the liquefaction potential assessment of soil is done or not. If it is done, then accordingly the bearing capacity, safe bearing capacity, or your pile capacity, all those things are accordingly assessed or not. So these are the very important aspects, right? Now, you see, when you are talking about all these things, I must tell you that your this IS code recommendation, it is based on a simplified method. Got my point? That means the research on liquefaction started in early 70s, or even slightly before that, because we are getting different papers during that period also. But it is so complicated, or it is very difficult to really assess the liquefaction potential that the code ultimately accepted after a long time. And with the note that if you want to, examine your soil, in a deeper way, and if you make some conclusion which are very important, then you can consider that. So what I mean to say that even now there is a huge scope of research, huge scope of modification. Got my point? So that you have to keep in your mind, because you will be in the profession for next 40 to 50 years. So if you really want to do something or contribute something, and if you choose one of your fields, this particular subject means liquefaction of soil, yes, you can do it. There is a lot of scope. It is not yet fully developed, right? Now, the question comes, why it is not moving? So you see, the causes of damage to structures during earthquake is due to occurrence of liquefaction in saturated sand deposits. That means not only sand, it may be sandy clay, or it means the quantities of sand is more. Sand dominates, right? If the clay is more, then there is no problem. But if there is a combination of sand and silt, yes, there is a definitely you have to be very careful about liquefaction, right? So it is that is why saturated sand deposit, not only sand deposit, means sandy soil. Liquefaction occurs in saturated soil in which the space between individual particles is filled with water. That you all know. In any soil media, between the particles, this always it is filled up with water. During an earthquake, seismic wave, travels vertically under undrained condition, right? Poor water has no time to move out. That you can easily understand. It's an undrained condition. So how the poor water will be able to move out, right? This is the situation. In saturated soil, the seismic energy increases in pore water pressure, and consequently, the effective stress decreases, right? Earthquake shaking increases the water pressure to the point at which the soil particle can readily remove with respect to one another. Got my point? This is the most basic way of describing the phenomena. Now, as a result, what is happening? Loss of shear strength, loss of skin friction, which is very important for piles, right? And the soil behaves like a fluid. Okay, so this phenomena is known as liquefaction, right? Now you see, these are the things very important, and you can even go through a subject, soil dynamics, right? Now, you see, just think about a pond. And if you just throw a stone in the middle of the pond, what will happen? The wave will generate, right? Similar kind of things happens in case of earthquake, right? And the, in the vicinity of the that particular point where you have thrown the stone, like if you compare it earthquake, that is the epicenter, then the immediately nearby that particular place will be affected a lot. I mean, it will be affected to a great extent, and slowly, the effect will be, will reduce. So that you all know, but this particular seismic wave, when it is passing through the soil media, different soil media. It is not that only sand or sandy clay or clay. It is passing to different, kinds of soil. How it is traveling? What is the physics behind it? What is the dynamics behind it? So these are the things, you will find it in soil dynamics. And this paper is, it is covered in Jadavpur University, but this subject itself is, is not fully developed, right? Now you see, this is just see this particular figure, photograph you have seen in the your internet. This is very common. 1964, the buildings collapsed like this. Something, it has tilted, then it is bodily went inside the soil. This is like this. So different kinds of things. But it is happening maybe under a particular building. Okay, maybe these buildings are not affected. These buildings are not affected to that extent. So it is not that it will always happen in a big area. Even in a small area, it may happen. And whatever the buildings are there or any structure is there, that will be, affected to a great extent. Even, in this case, it is collapsed, right? So, these are the things sometimes happens that here it is like this, right? This kind of collapse took place because of liquefaction, right? Now you see, roads are, cracked huge. There's a huge crack in the roads because of liquefaction. Bridge collapsed. Maybe, this piers are shifted or, settled, and that due to that, this collapse took place, right? Now you see that if you want to just, discuss this thing with the two lines, then what is that? That these are the particles. Particles means it may be sand plus silt, like that. Okay, but basically sand is soil, and these interparticle gaps are filled up with pore water, basically water. During earthquake, the saturated sand is vibrated, and as a result, the particles tend to come close to each other. So if the water goes away, naturally it will be like this, right? And the pore pressure, water pressure increases, and hence the effective stress decreases. And due to this entire phenomena, ultimately what will happen, that the bearing capacity of the soil will decrease, or if there is a pile, something is happening at a particular level, similar kind of thing, then the skin friction will be not only, I must not say zero, but it will reduce to a great extent, right? Now you think about this kind of thing. Before earthquake, suppose before earthquake, this is the pavement, this is the sediment layer, and this is the water saturated granular layer. Okay, like this, Okay, loosely packed veins and pore spaces are filled up with water. Now, during earthquake, when earthquake occurs, then what happened? It is just coming out like this. And ultimately, it is affecting the pavement. Though pavement is very good, but due to the huge pressure from the bottom, right, ultimately, it may come out. And if it is happening, then the whole thing will settle. This is one of the types of liquefaction. There are different types of liquefaction. So basically, the way I explained to you, that is happening. Now this is basically the factors, right, which are affecting the liquefaction. That is grain size distribution, soil type obviously, we should be basically sandy soil, relative density, earthquake loading characteristics. Because earthquake loading is basically depends that whether that place is very close to epicenter or not, depending on the magnitude of earthquake. So that is why this loading characteristics is very important. Then vertical effective stress and over-consolidation, age and origin of soils, degree of saturation, thickness of sand layer. Sand layer means sandy soil layer, not sand only, sandy soil layer. Now you see, when sand, predominantly sand. So all these points, don't think that everything is resolved. Don't think that people have done research and solved everything. No, not at all. So people have to think more about it, and ultimately they should resolve to a particular conclusion. They should come to a particular point and say, yes, now we can codify it, and then only the industry people will get it, and the subject will be discussed in detail and included in the design process. That should be our aim. Now, sand boils quicksand condition. You all know quicksand condition, and this is happening. Toe failure, lateral spread, ground oscillation, loss of bearing capacity, buoyant rise of buried structures, ground settlement, failure of retaining walls. There are many. List may be a long list. But I'm just giving you something, telling you something so that you can have some idea, right? Now you see this kind of failure took place. That if you go to internet, you will find this photographs, right? And this kind of, it is happening in desert, but in many places, even in the city, it may happen like this, right? So keep this thing in your mind, the sand boils, right? Now you see that the loss of strength is associated with increase in pore pressure, and the softening of soil occurs during liquefaction. That already I told you. And because of that, it will lose its shear strength. That means actually the bearing capacity, right? Leading to large settlement or tilting of structures. This is the thing. Either it will bodily just settle, whole structure is, just as the whole settling down, or maybe like this, tilting may occur. Both are dangerous. If it is like this, then also we don't like it. If it is like this, then immediate collapse may take place. Immediately, here collapse may not take place immediately, depending on the foundation type. If it is raft, then it is different. It will not collapse immediately. But even if it is raft and it tilted, then it may collapse. Got my point? It may collapse. So that we have seen from those photographs, which I have shown you. Now you see, due to this, the difficulties in obtaining the you can say undisturbed samples, because sand, the more sand means it is difficult to get undisturbed soil. That those who actually spend some time in the industry, they know that when we are collecting the sample, if there is sand, it is difficult to get the undisturbed sand soil, soil sample, which we can go for triaxial test, some other test. It is not always very easy, right? But unless we know the soil property fully, then it is not really possible to evaluate the liquefaction potential. That is very important. So now we know something about it, but I think that more research is required and many things have to be added, and how we can go for other testing. Yes, there are different other testings are also made from which this liquefaction and potential assessment is done. And that also I'll mention. And in 71 seat and IDRIS, they actually propose some simplified method. And then this simplified method is They modified in 79. After that, in 96 also there is a report came out from this NSF, uh, National Science Foundation of USA. So, and many experts, they published papers in this particular journal during that period, and workshops took place. But around 2000, actually we got huge amount of informations, research reports. And depending on that, we can do something. We can do something, we can go forward. This kind of situation, was there around 2000. But after that, everything depends on the, speed of the implementing those information which will be available in the code for practicing engineers. That varies from country to country. So that ultimately happened in our country in 2016, right? Now, in our code, based on those reports, basically, because you have to confess that, that what are the important reports available at that particular time, and the code committee assessed those reports, and researchers, they have given their opinion, and ultimately in 2016 is part one. They have proposed a very simplified method, right, for assessment of liquefaction potential. And these methods are based on either standard penetration test SPT value, or cone penetration test CPT value, or shear wave velocity value. That means in one method, they have only considered SPT value and they have assessed the liquefaction potential. Another method is given where they have considered CPT value and they have assessed it. And another, method available in the IS 1893, shear velocity method, right? So if you have, standard penetration SPT value, if you have CPT or this, one of this, you can assess it. Or if you have all these three, you can assess the liquefaction potential separately and take the worst effect. In my recent book, I have solved problems with all these three methods with practical data. And ultimately, I have shown how to finally get the factor of safety, and then how to comment on liquefaction potential. That means the assessment report, how to do that. So all these things I have given in my recent book. Now you see, this is a board log data. Something, I don't know, somewhere we got it. This is one board log A1. This is another board log A2. Right? The board hole A1 and the board hole A2. Right? And what are the soils available in different zones that we have mentioned. Right? And accordingly, the deposit here is this similar kind of deposit up to this. Then this kind of deposit here, it continues here, but it just stopped here, like that, Basically, three kinds of deposit, but the depth is not same for A1 and A2. It happens, and that is the typical data is given here, right? Now, this is a particular table. I'll come and discuss about this table later on. You see, this is the depth, a different depth, 1.73 from GL, 3.18 from GL, like up to 18.23 up to GL. This data, what is the N value? Means SPT value. These are the SPT value, we got it. And then this overburden pressure, effective overburden pressure, and all these small parameters, how we calculate it according to IS 1893, right? And ultimately, After doing all these things, right, because many values are taken from IS 1893, and then ultimately we calculated the factor of safety. Okay? And see, the factor of safety, wherever it is less than 1, it is liquefiable. But this particular layer, the factor of safety is more than 1, so it is non-liquefiable. Again, it is less than 1, less than 1, it is also greater than 1, it should be liquefiable. But somehow I have missed, right? So this is also liquefiable. Okay. So if the factor of safety, according to the code, how they calculated factor of safety, that's a long process. And you see, at this particular layer, they got 1.138, so it should be liquefiable. If it is greater than 1, it is liquefiable. What does it mean? What does it mean? If we know that this particular layer is liquefiable, right? This particular layer is liquefiable. That means when we will calculate the, the carrying capacity of a pile, then these two layers are to be omitted. That means you have to consider that is this layers and this layer are not, providing any skin friction, and you have to just omit these two layers. Okay, you can't consider the effect of these two layers because you don't have any data, right? What is the value of skin friction and all? Accordingly, you will find that the pile capacity will come down. Obviously, you are not considering these two layers. Naturally, it will come down. But if somebody is not doing that, at least before 2016, nobody did that. Then what will happen? They will consider all the layers. They will never go this kind of analysis. So what will happen? The pile capacity will be very high. But if you consider liquefaction, then it will not be them. It will not give you that value. These two layers are to be omitted. Naturally, pile capacity will not be the same. It will be much less than that. So that is the problem. That is the problem. Now you can't do that. Now if you sign on a drawing, you have to consider, you have to write, even the geotechnical engineers, they have to write that all the soil properties, bearing capacity, skin friction, whatever it is, right? All these things are, obtained by considering the liquefaction effect. The liquefaction potential is evaluated according to IS 1893. And after that, they have recommended the pile capacity or whatever it is. So you can easily understand that. It happened to me in a particular project. One project, big project, in one project, the soil report, they recommended some pile, capacity, which was around 60 ton. And when, they started that project, after that something happened internally, that project got delayed by 3-4 years. And during that period, they wanted to take opinion from other experts that whatever they did it, that is all right or not. Now, in between, the 2016 code, it has reached in the market. And naturally, when I assessed it, I have considered IS 1893, 2016, and the pile capacity, whatever I found, it is not 60 ton. Then I told them to revise the pile capacity. But, they said that all the designs are done, pile cap done, everything done, the number of pile will be more. Then what? They don't know. They said that, let us keep it this way. I said that how can you? I have to write on the drawing, or I have to give a certificate that this pile capacity, everything is you know you know whatever we have used. That is after considering the liquefaction effect. Liquefaction potential assessment is done. Then they said, oh, yes, that is also correct. And then the whole thing is modified, and then new foundation was designed, and then the project, they started working on the project, right? So that's why I tell you that it is not that something is in the IS 1890, nobody is accepting it. No. I am talking about it in a very big project, okay, where I was the consultant. Similarly, when you are considering the A2, then also you are getting the factor of safety values. Okay? If it is more than 1, then obviously it is liquefiable. But it is very close to 1.02. Probably, I don't know why I have missed this, right? Probably it's a mistake from my side. So, this has happened. Okay? If it is less than 1, oh, right. So you have to at least get 1. If it is less than 1, then obviously liquefiable. Now you see, this is the graph you can plot. Borehole 1, this is your factor of safety, right? It will determine whether it is liquefiable or not. This is 1, and this is your depth. This is your depth. From the ground level, the depth of that particular layer, right? That is this particular thing. So this is 1, and it has come here. It is something, 16.3 something. Got my point? So the entire zone, less than 1. You can't consider it. Just imagine, not a matter of joke, 16.3. Okay. Similarly, for borehole 2, when they did it, then it is like this, 8.6. Right? This is 8.6 meter. So up to 8.6 meter, you can't consider. So from this 2 boreholes, this is giving you higher value. And if these 2 boreholes are very close to each other, to be in the safe side, I should go for this 16.3. Got my point? Otherwise, I may think that, if these boreholes are, the distance between these 2 boreholes are very high, in that case, I may think individual results. But if they are very close to each other, then obviously I'll go for this one, higher one, because to be in the safe side, right? Now, this is a typical sample calculation at a particular depth of 6.18 meter. How I have calculated the, this factor of safety according to IS 1893 Part 1 2016. That is given. Okay, I'll discuss this. I'm just showing you what will be there. All these things will be there, right? All these things will be, I'll discuss in detail, don't worry. So each and every method is given. Each and every method is given, that how I calculated the factor of safety at this level, right? In your, even in your, when you will be in the industry, you have to do all these things, right? So ultimately, the factor of safety is 0.47. Hence, the soil is liquefiable. This is the final conclusion. Got my point? So, at least I can tell you that once I discuss all these calculations in detail, you will be also able to do it, right? And this I have done it for a particular level, 6.18 meter level, depending on the soil properties available there. Similarly, at different layers, the soil properties are different, N value is different. Naturally, this factor of safety value will be different, right? Which I have shown you in the previous tables, right? Which I have already shown you that already you see. This is the table at different levels. Got my point? This is the table. Got my point? Out of that, this 6.1 meter, this particular data, how I got it and how I arrived at this figure, right? Factor of safety, that I have shown you in detail. But other things also calculated, but that I don't think that, I have to show you at every level, because only N value is different, other properties are different, and accordingly this change is made. That one can do it easily in Excel sheet. That is not a problem, right? So this is about your this evaluation of liquefaction potential. I'll come back to this again. I'll come back to this. That probably after discussing the code, right? So I think I should come back from this point. Okay, from this particular point, I'll come back. Okay, now let me open the code. So this is the IS 1893 Annex 5 F, right? And the procedure is given here, right? Procedure is given here, right? Now, you have to go through it carefully. Steps are given. So I'm going through this slowly. Don't worry. This is not a very complicated method, very easy method, right? Very easy method. And whatever the values are required, that is available here. So one can do it. One can find out factors even without knowing soil mechanics much. But what I told you, that is very important, that this method is not, Bible. It is not above criticism. But at least a golden beginning started. Nothing was there in the code. Now at least it is, something they have given. Maybe within another few years, maybe 2-3 years, this method will be modified or maybe better presented. But whatever you are finding here, right, these equations, etc., all you basically, see an Idris contribution and many other researchers' contribution. Got my point? So those who have decided to contribute in the field of civil engineering, in the geotechnical, in structural engineering, they are not foolish people. Money is not everything in life. Because some people, they worked hard in the laboratory, they worked hard with the analysis, and ultimately they could do something which others are enjoying. Those who are in the industry, they are getting some method, right? And this is the fruit of their work. So that is why I must tell you that if you go through research or you want to do something new, innovative one, please do it. And I don't think that you will suffer a lot. At least, some uh, living standard you can maintain. But at the end of the day, the entire civil engineering fraternity, they'll be very happy. They'll be very happy because they will be able to use a particular method through which they can assess the actual situation to some extent, and the damage can be avoided. Collapse can be avoided. What else you want? Is it not? In this short life, if we can do something very good for others, and that is always good. And that's why now if you go through different books, right, you won't get always the liquefaction potential calculation according to the actual data of the field. You may not get. Then that's why I thought that I should at least solve three problems with three different methods recommended by in IS 1893, and I should include in my book. And I did it, basically, I tell you that it is a CRC publication, Taylor and Francis. Naturally, the book will be circulated throughout the world. So it is good that people will use it. After that, they will discuss it. And maybe after 2-3 years, something better will come out. Again, if I am alive, then I can revise those things, make my comments, right? And with this, plus if you do something, some research of your own, I don't know, that is the best possible thing which one can think in a particular life. So don't worry, just try to contribute something so that the entire engineering fraternity becomes very happy, not only with the subject, with you also. Now you see, due to difficulties in obtaining, why I'm reading every line, because every line has got some meaning. And from this, you can easily understand that the limitations of the methods, right? Due to difficulties in obtaining and testing undisturbed representative sample from potentially liquefiable site, in situ testing is the approach preferred widely for evaluating liquefaction potential of soil deposit, which I told you. It is sandy soil basically. In sandy soil, it is difficult to get, undisturbed sample. So how can you conduct your triaxial test and other tests? So that is why they have given more importance to the field test. That is the SPT, CPT, shear velocity, all these things we obtain from field test. So that they have mentioned here clearly, which I have already told you. Liquefaction potential assessment procedure involving both the SPT and CPT value are widely used in practice. Yes, because when I was in Nigeria, at that time, we used to use SPT, CPT both. Right? We had a separate division for geotechnical investigation. We had our own sophisticated instruments, very, very sophisticated, costly instruments. And as I was heading, naturally, I had access to everything, and I used to advise them. I used to learn from them. Right? The most common procedure used in engineering practice for the assessment of liquefaction potential of sand and silt. Okay, these two are important. Sand and silts is the simplified method. That is, they said that till today we are accepting that. That is, the method which I was telling you, right? Seed and Idris. The procedure may be used with either standard penetration test, blow, count, or cone penetration, tip resistance, or shear velocity. Got me? This is shear velocity. That is also another test. I don't know whether you know or not, that they make some hole in the ground and then they insert the, some kind of instrument there, and then they generate some wave from that instrument. They can generate. Similarly, they make a hole at a particular distance. That means there are two holes. In one hole, they are generating the wave, and in the other hole, which is at a particular distance, uh, that particular hole is receiving that wave. Like in ultrasonic pulse velocity, what you are doing? There are two transducers, and what you are doing, you are generating a sound wave, and that is passing through concrete, and the other transducer is receiving it, and you are ultimately getting the time. You are getting the time. How much time it is taking to receive that particular sound wave, and from there you get the velocity. Is it not? Distance divided by time. And ultimately, if the velocity is very high, that means it is like metal. In steel, it's very high, 25. And where is concrete? Good concrete 4, bad concrete 2, like that. Okay. So whatever it is, I mean to say that the velocity is very important when it is traveling through a particular media, because if the velocity is very high, then it is something. Velocity is very low, it is something. So that kind of shear wave velocity, we do it. Sometimes when it will be a hilly area, you can't do it, or in a particular place you can't go there. Then, but there is a long distance between them. Then you can go for this kind of test, and you will get some shear wave velocity, and which will help you in assessing the liquefaction potential, right? Now you see this. Let me increase the font. So just see. Can I make it 100? Yes, this is the maximum. So you see, step 1, the surface data used to assess liquefaction susceptibility should include the location of the water table. That's very important. Either SPT blow count N, that you all know, or the tip resistance QC, which is given by CPT. Many of you don't know about CPT. In India, mostly these SPT values are used, CPT value less. But in Calcutta, most of the companies, they don't have CPT machine. And they or shear velocity value and fine contents of the soil, that you can easily do it, even if it is disturbed sample, doesn't matter. And the percentage passing through IS standard 75 micron. This is the first thing to do. That is the field test, and along with this, fineness, fine content, that is to be obtained. In the second step, evaluate the total overburden stress, right? That is, or effective overburden stress at different depth, right? This is why important, because if the overburden pressure increases, then the soil is already stressed. That means in the upper part, the overburden stress is less. As you are going to the lower part, the overburden stress is more. So that has got an effect in the ultimate analysis. And to get the overburden pressure, that is not an issue, because you know the density of soil. If you just multiply by depth and all, you will get it. That is not at all issue. Okay. Then, evaluate stress reduction factor RD. This is obviously an empirical formula, right? Where they have given what is Z, the depth on the ground surface, and you will get RD. So this is nothing to, at this stage, you have to consider it as a Bible. You can't really criticize it or, try to understand what it is. It is just a parameter, you know, um, which is used in the liquefaction potential, right? Now, I must tell you one thing that, whenever you are going through something which is not known to you, then you must know your limitations. Limitations means that you have got some knowledge, and depending on that, you know, you will be able to really appreciate the equation, means to some extent. Not that the way a particular geotechnical man who has got a lot of expertise, a lot of research, understanding of soil mechanics, you may not be able to understand that way, and accept it. Accept it. Why? Because you have to be knowledgeable. Then you have to go into the deeper part of it. Because regarding RD, if you go through internet, you will get several papers. So you will slowly understand that why this equation is like this, why it is 1.174. It is not somebody has done it. Many people did many things, and after that, finally code accepted this. Okay. Like in wind code or seismic code, similar kind of things are there. Calculate cyclic stress ratio, CSR, induced the earthquake. This is the expression. This is, the peak acceleration by G, this particular thing, right? For some places 0.16, for some places 0.24, depending on the seismic zone. This is overburden, that whatever you calculated stress ratio. RD is just now you have calculated. So you get it. You CSR, you get it. Okay. Now, if value of PGA, right, is not available, then this may be taken from code. That means what they're saying, that if somebody has got the microgeneration data, or the seismic data, and from there if he can calculate the value of Max by G, let him do that. If it is not available, mostly in the industry they don't have available, then they should go for table 3, which we have used, which we have used in IS 1893. Because why they are saying like this? Because in many projects, this PGA is developed and microgeneration, based on microgeneration and all. And accordingly, the values, if they are found more than the code value, then they are going for the higher value. Because when you are investing so much, then if you consider some code value, and if it is on the lower side, gives you lower best shear, then actually the building, the structure will collapse, and you are investing a lot. So depending on the investor and the importance of the building, we always go for we are not always blindly following code values, but rather we go for separate kind of microgeneration analysis and do it separately. Okay, and just check it whether the value is coming higher or lower, and accordingly we take the decision. Then you obtain the cyclic resistance ratio, CRR, correcting this one, because this is Richter is 7.5, something is given, but your Richter value may be different. So accordingly you have to correct it for earthquake magnitude, high overburden stress, all these things. You have to make some correction at this stage. Okay, so that correction is made like this. The correction is made like this, right? This magnitude scale factor they calculated like this. And MW is nothing but that Richter value, right? When I'll show you the calculation, it will be very clear. But this is basically, I tell you, it is mechanically you have to do it, because these equations they developed, after a lot of research and all. So no point discussing this thing here. Now, the ultimately the correction of high overburden pressure. This is obtained. All these things, if the depth is greater than 15 meter, you have to use this particular equation, right? So all these finer details are there, that depending on the relative density of the soil, the 40 to 60% is F equal to so much, then 60 to 80% is so much. So all these things are given, right? So here also, when you will be solving the problem, then it will be very, very clear that why you have used F equal to something, definitely depending on the value of relative density. Relative density also is very important here, right? So SPT, this one, that you will, if you calculate your factor of safety based on SPT, then 6A, step 6A is important. If it is based on CPT, then 6B. If it is based on shear wave velocity, it is 6C. Got my point? So now I will show you 6A. Of course, 6B, 6C is there. That is, all these things are given, available in my book, right? But, today I'll just consider 6A. That based on CPT value, the SPT value. It can be done with and this value also, right? Then this is cyclic resistance ratio that is to be obtained. Now then the SPT value, all these parameters, C60 and all, the SPT value is to be corrected. So depending on the hammer efficiency. So these are the few things are there that it will be clear when I'll do the the numerical analysis, the numerical example. Then all these things they have done it. Then finally they got this value Cn equal to so much, and then they go for it. This is another expression, right? You have to be very careful that what they are recommending. This fineness content less than 5 is this, less than 35 this, greater than 35% this. So you have to be very careful, right? That depending on your fineness content, you have to consider the beta value. Similarly, you will be getting the CRR 1.5 based on the previous values. And when you will be doing it, all these things, I've shown you this corrected blow count and all. You have to consider these graphs also, right? These graphs also you have to use, and you have to get this kind of ratio, right? So that is 6B using CPT value. That I am not showing it now, right? And then after that, basically, ultimately you will get factor of safety, this CRR and CSR. CRR, I told you how to calculate. CSR, how to calculate, and that issue is very important. Then, they have written, that the factor of safety is less than 1, then the soil is assumed to liquefy. So up to this, today I'll discuss just with a numerical example. Got my point? So I don't think that this procedure is very complicated or very difficult to understand. I don't think so. Very easy to understand. And I'll show you how to at least find out the factor of safety at a particular level based on SPT value, right? So now let us go back to the previous year. Now you see that up to 5.95 meter level, right? The soil is basically clayey soil. Okay, so this is not our headache. Here the same thing up to 4 meter level. It is basically a clayey soil. For clayey soil, we don't have any headache. The liquefaction takes place in sandy soil, where sand is more predominant, right? Playing the major role. Now, these are the things, this table you see, all those parameters which I told you that they calculated and made this table. And how they calculated these parameters, that I'll show you. This fineness content they have entered. Whatever the soil data in value they have entered. And then step by step, they calculated all these parameters. Ultimately, factor of safety, right? This is about borehole 2. And this is I showed you that up to a particular depth it is less than 1. Beyond that it is greater than 1. And see, this is a particular data for borehole A1 at 6.818 meter level. Now, here, water table is given 0.8 meter from ground level, layer certification from 5.95 to 6.4. Okay, in this particular layer, the soil properties are given. Average depth they have calculated, just this plus this by 2. N value at this level 10, they got it. In Kolkata also it is coming 7, 8 or 10 like that. Bulk density of soil is 1.9. Atmospheric pressure, yes, it is a parameter also, it is required, 10. Now this total overburden pressure is 6.175 into 1.9. And effective overburden pressure is nothing but that gamma W is to be minus gamma W, this gamma soil minus gamma W, all you all know. So this is the thing, right? Now it is 0.8 meter. So that particular effect is to be considered, right? Because water table is up to 0.8 meter, we are considering at 6.18. So that gamma S minus gamma W, that particular term, it will come. It will come, right? If the depth is less than 0.8, then you are not to consider this gamma W, right? So then RD, at this depth RD they have calculated using this formula, simple, just putting Z, they got it. Then the CSR, this from table 3, this is a place in Kuch Bihar. So there, this value is 0.24. It is coming in zone 4. So if you do this calculation, it's 2.1. CSR is 312. CSR, if you just put it in this, which I have shown you already, you will get CSR equal to this. Okay. And then your CRR, this CRR 7.5, and that is to be calculated from this step 5. Then MSF 7.7, they corrected it. With this expression, they have corrected it. They have calculated MSF. And after calculating MSF, they have inserted here and they got the CRR. So Ka they calculate, then they call the CRR. Okay. So these are all nothing but just using the formula. You have to be very careful about the formulas and its limitations and everything. And accordingly, if you just use the formula, that is, you are not wrong according to IS 189. right? So be careful about putting data. Now you see, this is some correction regarding hammer, right? That is given here. If you go through the code, you will be able to understand that everything is given for a particular hammer. If the hammer weight and or the drop height is different, then you have to make some corrections. So those corrections are made. Those corrections are made, and you see all these things: loose sand, the rod length, borehole dia, all these things are there, and they got the C60. This is C60, one parameter they calculated, right? All these things are regarding, this modification of n value, right? Now this correction factor, they made it, then they got it 1.34. Then the n value was 10. Now they have corrected it. The correction factor, ultimately they got it 8.06, and they corrected it. And this 1.34, they got it in 160. This is required. This will be required for further calculation. So it is 10.8. Now sometime this value is much more than this. So if you just take n equal to 10 and do the solve the problem, then you are wrong, right? So be careful. This correction is very, very important of n value. Many people are not at all caring. Now, similarly, the finance content is 7% at that level. So it is in between. So accordingly, they have used the formula for alpha and beta, right? They got this further correction, corrected value, right? After fineness is this 11.028, right? Now then your CRR, I'll send you these calculations. Don't worry, okay? And this value they have calculated. Then CRR is this, CSR is this. Then the ratio of these two is factor of safety. That they got 0.47. So you have to do it up to this level. Now similarly, if you have got your CPT value, you can do it by using your 6B, log 6B, and you will get some value. If you have got shear velocity value, right, you have to use step 6C. Accordingly, you will get your factor of safety value, and out of this you will consider the lowest one. If you have got all the three values, you will consider lowest one, because ultimately you have to identify whether the layer is liquefiable or not. If it is liquefiable, then you can't consider any skin friction there while calculating the pile capacity, right? And the second thing is very important, that it has got, if it is happening within say 3 meters or 2.5 meters, even if it is shallow foundation, the value is going to affect the bearing capacity also. Value is going to affect the bearing capacity also. So basically, I tell you that for the shallow foundation, generally it is not giving trouble, but for piles, in many situations I found that in between layers are extremely bad, but we are considering that, and the pile capacity we are showing very high. So these are the things you have to keep in your mind. Like I'm telling you one example which I have experienced in your Nigeria in a bridge project. So you used to go to the middle of the river, and in the PL location, from a particular barge, we used to drive our tube and collect the soil sample. And also, one day what happened, then when we were driving, then suddenly huge amount of water is coming from the bottom, huge. And we could not stop. We had to stop the entire work immediately. And then, I was in the head office. I was called, and I could reach there within 3 hours, because from there, I straight away went to the airport. It will take 1 hour from there to site. So at least 3 hours I took to reach the site. Like, from here, if I want to go to Guwahati, it is at least, this 1 hour is required. And, luckily, the flight time also helped us. So when I reached there, that is around 2 p.m. Around 2 p.m. So what I told them after going to that immediately, that you push the tube further, at least for 1 meter, at least for 1 meter or more. And they did it. They pushed the tube, and for more than 1 meter, and the water stopped. What was my impression? Maybe there was an aquifer, and that the aquifer normally 1 meter, 1.2 meter, or sometimes more, and this tube was passing through an aquifer, and that is why this water is coming. It immediately struck me, and just think about it, that at a particular level there is full of water only. That 1 meter is full of water. That is as if it is a floating land. So you think about a particular layer, that which is liquefiable, and during earthquake, what will happen? That will not be like water, but it will be a liquid. It's just a liquid. So you won't get any skin friction from that particular layer while calculating the pile capacity. So you have to remember these things. And I have seen several problems, and I had opportunity to solve those things also during my stay there, right? Because unless you face the problem, you will not be able to really think that what is going to happen. And for a company like where I work, if you stop the work for a day, then you are losing huge money. That means the barge, rent of the barge, and then the persons who are working there, all these things, if you add it, it's a huge amount. So you have to solve the problem immediately. Immediately. You can't make any delay. So you see, based on my experience in India and also in Nigeria, in different places, I must say that that we should work more on liquefaction, right? And to arrive at much accurate or reliable method. These are also reliable methods, but we should work hard. And for the time being, whatever we have in the code, this IS 189, we should strictly follow this. Don't think that it is nothing. It is given, we will not follow. That is the attitude of some engineers. No, don't do that. Please apply this IS code recommendations regarding liquefaction potential, and accordingly find out the capacity of pile, or if it is applicable for the bearing capacity calculation, do that. Right? There is no other choice. Thank you very much. Thank you very much for listening to me. We will meet you in near future. Okay, I'll definitely meet you in near future discussing more about it. Okay, thank you very much.